Today we're going to learn how to solve equations that have variables on both sides. You should be on page 8 in your notes packet. Your first equation says 10n minus 5 equals 8n plus 11. When we were working on multi-step equations, we always checked on either side of the equation, so the left side and the right side, to see if they could be simplified. Well, when I look on the left side of the equation, there are no like terms because 10n minus 5 are not like terms. On the right side, there are also no like terms. 8n and 11 are different, so I cannot combine those either. What I do notice is that I have the variable n, but I see it on both the left side of the equation and on the right side of the equation. Well, when I'm solving an equation, I really need all of my variables on the same side because the goal of an equation is to isolate your variable. You cannot have two of them. So what I need to do is to eliminate one of my n's. I usually go with the variable that has the smaller coefficient. So in this case, 8 is smaller than 10. So I usually would try to eliminate that. Here's where you really need to pay attention. If I were trying to solve an equation and maybe it said 8n equals 24, if I wanted to get the 8 away from the n, we would always divide by 8. However, in this case, I'm not trying to get the 8 away from the n. I'm trying to get the whole term of 8n away from this side of the equation. To do that, I have to figure out what would I do to 8n to make it so that it just went away completely. Well, I would think about the fact that this is a positive 8n. Well, if I subtracted 8n, if I did 8n minus 8n, then I'd be left with 0. So if I did that, they would cancel out. So I'm going to subtract 8n from both sides of this equation. When I subtract 8n on the left side, 10n minus 8n leaves me with 2n. I'm still left with minus 5 on this side because this didn't have a like term. It's still there, so I can't forget about it. On the right side, I have 8n minus 8n. That is 0 because they cancel each other out. 0 plus 11 leaves me with 11. Now I have a two-step equation and I'm going to solve it like normal. So once you have moved your variables, you should just be able to solve this like you have solved every other equation. You always would start with your eliminating of adding and subtracting. So I would try to get rid of this minus 5 first. I would use the inverse, which is adding 5 on both sides. The negative 5 plus positive 5 makes 0. So these will cancel out. I'm going to bring down my 2n. 11 plus 5 gives me 16. Now I do need to get 2 away from n, so I see that 2 is being multiplied by n. Well, I'm going to use the inverse, which is dividing by 2, and I'm going to do that on both sides of the equation. These 2's will cancel to leave me with n equals, and then 16 divided by 2 is 8. So n equals 8. Next, I have 7x minus 19 equals 3x plus 21. Before I start, I always want to look on the left side of the equation. So I have 7x minus 19, and I see that there are no like terms over here. Then I'm going to look at the right side of the equation, and I just see 3x plus 21. There are no like terms over there. So because of that, I can start looking at how am I going to solve the equation. Well, I see that I have a variable on both sides. I have a 7x and a 3x. Like I said before, I typically try to move the smaller coefficient. So I would try to move the 3x. I am going to look at 3x and I see that it is positive. So if I wanted to eliminate positive 3x, I would subtract 3x because if I did 3x minus 3x, I would have 0. so they would cancel each other out. I remember that I need to do the same thing on both sides of the equation to keep my equation balanced. Now, if I do 7x minus 3x, I get 4x. I still have this minus 19 that I can't forget about, so I'm going to rewrite minus 19. 3x minus 3x is 0, so these cancel out, and 0 plus 21 is just 21. Now I have a two-step equation that we all know how to solve. So I just am solving 4x minus 19 equals 21. Well, to do this, I need to start with my adding or subtracting. So I'm starting with this minus 19. The inverse of subtracting 19 is adding 19. So I'm going to do that on both sides of this equation. This works because if I have a negative 19 plus 19, that's 0. So those will cancel each other out. I'm going to bring down my 4x and my equal sign. 21 plus 19 gives me 40. Now x is still not by itself, it has this 4 with it. So I see that 4 is being multiplied by x. So I'm going to do the inverse and I'm going to divide by 4 on both sides. My 4 divided by 4 is 1, and those cancel because 1x is the same as just x. Then 40 divided by 4 gives me 10. So that means that my solution is x equals 10. Next, I have negative 15h plus 7 equals negative 10h plus 57. Again, I still start by looking at the left side. I have negative 15h plus 7. There are no like terms there, so I also need to check the right side. Negative 10h plus 57, there are no like terms there. So I cannot simplify any part of this equation. Instead, I can just start using my inverse operations. Well, I see that I have an h on both sides of this equation, so that means I need to get those together. Well, I'm going to start with the coefficient that is the smallest. Well, actually, negative 15 is smaller than negative 10. So I'm going to move my negative 15h. Now I see that there is a negative sign, which is the same as a minus sign in front of that 15h. So the inverse of that is positive 15h or plus 15h. And I'm going to need to do that on both sides. Well, this works because if I do negative 15 plus 15, that gives me 0 because those are opposite numbers. So negative 15h plus 15h cancels out because they make 0. If I have 0 plus 7, then I am left with 7. On this side of my equation, I have negative 10h plus positive 15h, so negative 10h plus 15h. That gives me positive 5h. I also have plus 57 on this side of the equation that I need to rewrite. So now my equation just says 7 equals 5h plus 57. This is now a two-step equation, and we all know how to solve those. So we're going to start with our adding. So we're adding 57 here, and I need to use the inverse, which is subtracting 57. And I'm going to do that on both sides of the equation. 7 minus 57 gives me negative 50. On this side of my equation, 57 minus 57 is 0. Well, if I did 5h plus 0, I would just be left with 5h. So those cancel each other out and leave me with 5h. Now I still need to get h by itself, so I need to get rid of this 5. I see that 5 is being multiplied here, so I'm going to use the inverse, which is dividing by 5 on both sides of the equation. Now we need to be careful right here because this does not say 50 divided by 5. It says negative 50 divided by 5. When I have negative 50 divided by positive 5, I'm going to get an answer of negative 10. On this side of my equation, 5 divided by 5 is 1, and if I have 1h, that's the same as just h. So the 5's cancel to leave me with h. This means that my solution is negative 10 equals h. Let's look at our next equation. 11 minus 6k equals negative 10k minus 13. Well, again, I'm always starting with the left side and the right side and seeing if they can be simplified. 11 minus 6k has no like terms. Negative 10k minus 13 has no like terms. So now, since neither side can be simplified, I'm just going to start using inverse operations. I do see that I have the k on both sides of my equation, so I need to move one of those. Like I said before, I usually try to move the one that has the smaller coefficient, although you could move either one technically, and as long as you're very careful with your positive and negative numbers, you should still get the right answer. Now in this case, this k has a coefficient of negative 6, and this k has a coefficient of negative 10. Well, negative 10 is smaller than negative 6, so I'm going to move my negative 10k. So I'm going to use the inverse of what is happening here. In front of my negative 10, or in front of my 10k, I see that there's a negative sign, which is the same as a minus sign. So the opposite of that is a plus sign. So I'm going to do plus 10k on both sides of this equation. Well, I haven't done anything with this 11, so I'm going to rewrite 11. And right here, we have to be careful because this is a negative 6k because of that minus sign. So we're doing negative 6k plus positive 10k. So negative 6k plus 10k, that gives us positive 4k. Because the 4k is positive, we're going to write plus 4k. Then we have our equal sign, and on the right side of our equation, we have negative 10k plus 10k. Well, those make 0, so they will cancel each other out. And then I have 0 minus 13, which is just negative 13. Now you can see that we have a two-step equation, 11 plus 4k equals negative 13. I need to get rid of my 11 first. And because this is a positive 11, I'm going to use the inverse, which is negative 11, or subtracting 11 on both sides of the equation. 11 minus 11 is 0, so these will cancel. And then 0 plus 4k just leaves me with 4k. Negative 13 minus 11, and you want to be very careful when you put this in your calculator. This does not say negative 13 minus negative 11. It literally says exactly what you see. Negative 13 minus 11. When you plug that into your calculator, you are going to get negative 24. Now we need to get k by itself by getting rid of my 4. I'm going to use the inverse of multiplying since 4 is being multiplied by k. So I'm going to divide by 4 on both sides of the equation. 4 divided by 4 is 1, and 1k is just k. So those cancel out and leave me with negative 24 divided by 4. When I divide negative 24 by positive 4, I get negative 6. So my solution is k equals negative 6. Next, we see 3m equals 12m minus 3. Well, again, I always want to check my left side and my right side of my equation to see if anything can be simplified. Well, the left side only has 3m, so nothing can be simplified there. The right side says 12 times m minus 3. Well, this actually can be simplified because I see that I would need to use the distributive property with my 12. So if I rewrite this equation, we're not doing anything with 3m, so we're going to rewrite that. But we need to distribute this 12 into my parentheses. And remember, when we distribute, we have to distribute to every term in the parentheses. 12 times m is going to give me 12m. Then 12 times negative 3, that's a positive 12 times a negative 3, is going to give me negative 36. Because that 36 is negative, I would need to write minus 36. Now when I look on the right side of my equation, I don't have any like terms anymore, so both sides have been simplified. What I do see is that I have the variable m on both sides of my equation. Well, I shouldn't have that, so I need to move one of those. Now, typically, I've said that I would move the one with the smaller coefficient, which would be 3m, because 3 is smaller than 12. However, in this case, if I moved 3m, then I would have everything over on the right side and nothing over on the left side. So for this problem, I'm actually going to move my 12m. Because that 12m is positive, I'm going to use the inverse of that, which is negative or minus 12m. And I need to do that on both sides of this equation. On this side, I have 3m minus 12m. And remember, that is not the same as 12m minus 3m. Order is very important when we subtract. When we do 3m minus 12m, we're left with negative 9m. 12m minus 12m is 0, so those will cancel out. And if I do 0 minus 36, that gives me negative 36. Now you see here that we don't have a two-step equation, we actually just have a one-step equation. So all we have to do is get rid of this m, or this negative 9. So we're going to do the inverse of multiplying. So we're going to divide by negative 9 on both sides. And you have to be very careful here, because a big mistake that I see with a lot of people right now is that they are not dividing by negative 9. If negative 9 is what's being multiplied by m, you have to divide by negative 9, not positive 9, because then you would still be left with an equal sign over here. So we have to divide by that negative 9 on both sides, and then those will cancel to leave me with m equals. Negative 36 divided by negative 9 gives me positive 4. So my solution is m equals positive 4. Next, I have 6k minus 10 equals 2 times 7k plus 3. Well, on the left side of my equation, I see that I have nothing that can be simplified. But on the right side of my equation, I see that I actually need to use the distributive property before I can start working. So I'm going to multiply 2 times 7k and 2 times 3. Now, when I rewrite my equation, there was nothing I could do with 6k minus 10, so I'm just rewriting that. But over here, I'm distributing, so 2 times 7k is 14k. Then 2 times 3 is 6. That's positive, so I would write plus 6. Now I can see that I have a variable on both sides of the equation, so I need to move one. For this one, I'm going to move my 6k since that's smaller. Since it's a positive 6k, I'm going to do negative or minus 6k on both sides of the equation. 6k minus 6k is 0, so these cancel, and then 0 minus 10 leaves us with negative 10. 14k minus 6k leaves me with 8k. And I still have this plus 6, so I need to remember to write that. Now I have a two-step equation that says negative 10 equals 8k plus 6. I'm just going to solve this like normal, so I'm going to get rid of my adding or subtracting first, so I'm getting rid of the plus 6. I'm using the inverse of that, which is subtracting 6 from both sides. Be careful over here and make sure that if you put this in your calculator, you put in exactly what it says, which is negative 10 minus 6. When I subtract negative 10 minus 6, I get negative 16. On the right side, 6 minus 6 is 0, so they cancel. And if I do 8k plus 0, that is just 8k. Now I need to get rid of my 8, so I'm going to use the inverse of multiplying since 8 is multiplying by k. And I'm going to divide by 8 on both sides of the equation. Negative 16 divided by positive 8 gives me negative 2. On this side of my equation, 8 divided by 8 is 1, and since 1k is just k, those cancel to leave me with k. So my solution is negative 2 equals k. Next, I have 5 times 2x plus 1 minus 4 equals 4x plus 19. I know that I need to distribute here first, So I'm going to start with this. Well, if I do 5 times 2x, that gives me 10x. Then 5 times positive 1 is positive 5, so I would write plus 5. Now you see that we also have this minus 4 here. That's not going anywhere, so I have to rewrite it as minus 4. On the right side of my equation, I have 4x plus 19. Nothing can be simplified over there, so I'm just rewriting 4x plus 19. Now on the left side of my equation, I still can't actually start moving anything because I see that I still have some like terms. I have positive 5 minus 4. Well, if I do 5 minus 4, that gives me 1, and that is a positive 1. So I really need to rewrite this side as 10x plus 1. The right side is still 4x plus 19 because we haven't done anything with that. Now when I look at the left side and the right side, both sides are simplified, so now I can start solving my equation by using inverse operations. I see that I have a variable on both sides, so I'm going to move my 4x since that's my smaller coefficient. Now that is a positive 4x, so I'm going to do negative or minus 4x on both sides. (10x minus 4x is 6x, and then I'm still left with this plus 1. 4x minus 4x is 0, and if I do 0 plus 19, I get 19. Now I can solve this two-step equation. I am going to subtract 1 from both sides of this equation. 1 minus 1 is 0, so those will cancel to leave me with 6x equals. 19 minus 1 is 18. I still don't have x by itself, so I need to get rid of my 6 by dividing by 6 on both sides. 6 divided by 6 is 1, and if I have 1x, that is just x, so they cancel out. 18 divided by 6 is 3, so I'm left with x equals 3. Next, I have 1/3 times 12 minus 9x equals x plus 8. I'm going to distribute my 1/3 first. Well, if I do 1/3 times 12, remember that if I'm multiplying a fraction times a whole number, I can put my whole number over 1 and multiply like normal. 1 times 12 is 12, and 3 times 1 is 3. Well, this really says 12 divided by 3. So 12 divided by 3 would give me 4. That means that 1/3 times 12 is 4. I also have to multiply 1/3 times not 9x, but this minus sign tells me that it's negative 9x. So if I multiply 1/3 times negative 9x, remember that if I have a whole number, again, I'm going to put a 1 under it. Well, 1 times negative 9x is negative 9x. 3 times 1 is 3. Well, this says negative 9x divided by positive 3. If I do negative 9 divided by positive 3, I get negative 3. So if I do negative 9x divided by positive 3, I'm going to get negative 3x. Because that 3x is negative, then when I write it in my equation, I need to write minus 3x. Now the right side of this equation, x plus 8, cannot be simplified, so I'm just writing x plus 8. Now both my left and my right side are simplified, so I can start moving my terms. I have the variable x on both the left and right side, so I'm going to move those. Since negative 3 is smaller than the 1, the invisible 1 that's in front of this x, I'm going to move the negative 3x, and I'm going to do the opposite of minus 3x, which is plus 3x. And I need to do that on both sides of the equation. Well, when I do negative 3x plus 3x, that's 0. And if I do 4 plus 0 or 4 minus 0, I get 4. So those cancel to leave me with 4. On this side, I have x plus 3x. Remember, there's an invisible 1 here, so this is like saying 1x plus 3x, which is 4x. I also have this plus 8 that I need to bring down. Now I just have a two-step equation that can be solved like normal. I want to get rid of my adding or subtracting first, so I'll eliminate this plus 8 by using the inverse, which is subtracting 8 from both sides. 4 minus 8 is negative 4. And when I do 8 minus 8, that is 0, so they cancel because 4x plus 0 is just 4x. Now I need to get x by itself by removing this 4. Since 4 is being multiplied by x, I'm going to do the inverse, which is dividing by 4 on both sides of the equation. Well, negative 4 divided by positive 4 leaves me with negative 1. On this side, 4 divided by 4 is 1, and 1x is just x. So they cancel to leave me with x. And my solution is negative 1 equals x. Next, I have 3.4x plus 2 equals 2.5x plus 5.6. Well, when I look at the left side of this equation, nothing can be simplified. And when I look at the right side of the equation, nothing can be simplified there. So I'm just going to start by using inverse operations to solve. Well, I see that I have a variable on both sides, so I need to move one of those. Since 2.5 is smaller than 3.4, I'm going to move that first. So since that's a positive 2.5, I am going to subtract 2.5x from both sides of the equation. 3.4x minus 2.5x leaves us with 0.9x. And then we also have this plus 2. On the right side of the equation, I have 2.5x minus 2.5x, which is 0. If I do 0 plus 5.6, I'm left with positive 5.6. Well, now I need to solve this just like normal. I am going to get rid of my adding or subtracting first. So I'm going to get rid of my plus 2, and I'm going to do that by subtracting 2 from both sides of this equation. Positive 2 minus 2 is 0, so those cancel to leave me with 0.9x. Then 5.6 minus 2 leaves me with 3.6. Now I'm just going to get rid of my 0.9 by dividing by 0.9 on both sides of this equation. These cancel to leave me with x equals, and 3.6 divided by 0.9 gives me 4. So my solution is x equals 4. Next, I have 4 minus 3x plus 2 equals negative 2x minus 1. Now I see that I have this parentheses over here on the left side of the equation, and there's something in front of it which tells me that I do need to distribute. Now you have to be careful with this because 4 is not next to the parentheses. So 4 is not what's being distributed. In fact, since there's nothing I can do with it yet, I'm just going to rewrite 4. But then when I look at that and I take the 4 away here, there's still something that needs to be distributed. What needs to be distributed here is the negative sign, which means there's really an invisible negative 1. So I would distribute negative 1 inside my parentheses. Well, negative 1 times positive 3x is negative 3x. So I would write minus 3x. Then I would multiply negative 1 times this positive 2, and I know it's positive because of that plus sign. So negative 1 times positive 2 gives us negative 2. Well, I would write minus 2 to show that it's negative. The right side of this equation does not have any like terms and does not need to be simplified, so I'm just going to rewrite negative 2x minus 1. Now I can solve this like normal, but I still have like terms on the left side of the equation. So I have the constant 4 and negative 2. Well, that's like saying 4 minus 2, which would give me 2. So I need to put those together. 4 minus 2 is 2, but I still have this minus 3x that I can't forget about, so I'm going to write minus 3x. Then I still have equals negative 2x minus 1. Now I can solve this by using inverse operations. I see that I have a variable on both sides of the equation. This is negative 3x and this is negative 2x. Well, I know that negative 3 is smaller than negative 2, so I'm going to move my negative 3x. Since that's a minus 3x, I'm going to do the inverse, which is adding 3x, and I'm going to do that on both sides of this equation. Well, negative 3x plus 3x is 0, so those cancel because if I do 2 minus 0, that is 2. Over here, negative 2x plus positive 3x would leave me with positive 1x. Well, positive 1x is the same as just x. But I still have this minus 1 that I can't forget about, so I need to rewrite that. Well, now I need to get x by itself, and I see that the only thing with x is this minus 1. So I'm going to use the inverse of subtracting 1, which is adding 1 on both sides of the equation. 2 plus 1 gives me 3. On this side, negative 1 plus 1 is 0, and they cancel out to leave me with x. So my solution is 3 equals x. Next, I have 3 minus 3/5 x equals 3/10 x plus 12. When I look at the left side of the equation, I see that nothing can be simplified. And when I look at the right side of the equation, I also see that there are no like terms here, so nothing can be simplified here. That means I can start using inverse operations to solve. Well, I'm going to solve by moving my variables so that they are on the same side because I have variables on both sides of this equation. Well, I see that this is a negative 3/5 x and this is positive 3/10 x. So any negative number is always smaller than any positive number. So I'm going to move this one. Since that's minus 3/5 x, I'm going to add 3/5 x on both sides of this equation. Well, negative 3/5 x plus positive 3/5 x is 0. So these will cancel each other out to leave me with 3 equals. But on this side, I have 3/10 x plus 3/5 x. Well, remember, when we're adding or subtracting with fractions, we cannot add or subtract them unless we have the same denominator. So we're looking for the least common multiple for 10 and 5. Well, I know that 5 is a factor of 10, so that means that I can keep 3/10 x and keep my denominator of 10. But I'm going to need to change 3/5 x so that it has a denominator of 10. Well, to get from 5 to 10, I would have multiplied 5 times 2 to get 10. I always need to do the same thing to my numerator that I do to my denominator, so I would also have to multiply 3 times 2, which would give me 6. Now you see that these fractions have the same denominator. Since the denominators are the same, all I would have to do is add my numerators. So 3 plus 6 gives me 9. Now I'm going to keep my denominator of 10, and then I have to remember that there's an x there. So 3/10 plus 3/5 is going to give me 9/10, or 9/10 x. Now I still have this plus 12 on this side of the equation, so I still need to rewrite that. Now my equation says 3 equals 9/10 x plus 12. All I have to do now is solve this two-step equation. Again, I start with my adding or subtracting, so I'm going to get rid of this plus 12 by subtracting 12 from both sides of the equation. Well, 3 minus 12, and again, be careful because that's not the same as 12 minus 3. 3 minus 12 is going to give me negative 9. On this side, 12 minus 12 is 0, so those cancel each other out to leave me with 9/10 x. Well, remember that 9/10 x means 9/10 times x. So to get rid of this, I would need to use the inverse, which is dividing by 9/10, and I'm going to do that on both sides of the equation. Well, if I look at the left side, this really says -9 divided by 9/10. Well, you would have to use your rule for dividing fractions, which is multiply by the reciprocal, which a lot of you learned as keep, change, flip, but it's really multiply by the reciprocal. So you would keep -9 and you are going to multiply it by the reciprocal or the flipped version of 9/10. The reciprocal of 9/10 is 10/9. So all we're going to do is multiply these. Well, we have a whole number and a fraction, so I'm going to put my whole number over 1 so that I can multiply. -10 times or -9 times +10 is -90. Then 1 times 9 is 9. Well, this really says -90 divided by +9, and that gives me -10. So when I divide -9 by 9/10, I'm left with -10. On this side, these 9/10 would have canceled and left me with x by itself. So now my solution is -10 equals x. My last problem says 5 minus 2x minus 4 equals -3x plus 3. We need to start this by distributing. So we see this minus sign, which means there's really an invisible -1 here. We're not doing anything with our 5 yet, so we're just going to rewrite that. But then we need to distribute our -1 into our parentheses. -1 times +2x is -2x, so I'm going to write minus 2x. Then -1 times, this is -4 because of the minus sign. So -1 times -4 gives me +4, and I'm going to write plus 4. On the right side of my equation, there are no like terms, nothing that can be simplified. So I'm just going to rewrite that as -3x plus 3. Now, I can't start solving this equation yet because when I look at the left side, there are still some like terms. I have 5 plus 4, which are both constants, so they can be combined. So 5 plus 4 gives me 9. Now I do still have this minus 2x, so I'm going to rewrite that as well. And on the right side, I have -3x plus 3. Well, now both sides are simplified, so now I can start using inverse operations to move my terms. I have -2x and -3x. Well, I'm going to move one of those. So I'm going to start by moving -3x since that's smaller than -2. Because there's a minus sign in front of that 3x, I'm going to use the inverse, which is plus 3x, and I'm going to do that on both sides of the equation. Well, 9 doesn't have a like term, so I just have to rewrite that. Then I have -2x plus +3x. Well, -2 plus +3 is +1. So this is like saying +1x or plus 1x. But remember, if I have 1x, that's the same as just x. On the right side, I have -3x plus 3x, which is 0, so those cancel out. And 0 plus 3 is just 3. Now I have a one-step equation that says 9 plus x equals 3. I need to get x by itself, so I need to get rid of this 9. Well, this is a plus 9, so I'm going to subtract 9 from both sides to get rid of it. Well, 9 minus 9 is 0, and if I did 0 plus x, I would be left with x. On this side, I have 3 minus 9, which is going to give me -6. So my solution is x equals -6.